Hey, hello, hello. How is everyone doing today? Let me make sure. Gotta turn my lights up a little bit here. How is everyone? Hope you're all doing well. That's the wrong one. Let's, there we go. It's a bit better. Not bad, not bad. Alright, let's see what we can do today. Hey, Mike. How was your weekend? I had a good weekend. It was nice. I took a bit of a break. It's Canadian Thanksgiving, so it was like a long weekend. It's always good to think about those sorts of things. Or think about those sorts of things. Take time off. And be thankful for things and whatnot. And here I am, back to work. How was your weekend, Mike? I hope things were well. So, I am gonna keep exploring different generative art ideas, and the whole point, well, the approach I'm taking is I'm gonna build, for each generative art sketch that I do, I'm gonna make a little web page for it, so you can use it to actually generate stuff. I think, there we go. So it does work. Let's bring the points way down. Let's just do that, for example. So I want to make this interface nicer, let you control more things and re-roll things independently. So you can really kind of tweak this to the perspective you want. So I might work on that, but I also want to start establishing my second idea, which is sort of blobs, not so much polygons, but we'll see where the stream takes us. I've got no strong plan, just want to get my head in the working game a little bit, you know? So the coding game again. I think I had food poisoning. I went out to eat Saturday night and was out of commission on Sunday. Oh man, that's I'm sorry to hear that. I shouldn't be laughing. That is not fun. Ugh, that's too bad. Hopefully you're feeling a little bit better today at least. Yeah, if it's like, if you're sick for one day, there's a reasonable chance that it's, yeah, something like food poisoning, right? Like if you're not still sick, at least that's a good thing? Yikes. Sorry to hear it though, that's not fun. Excuse me. It's a bit funny and I laugh about it, so it's fine if you do too. Alright, then we're in the clear. All better after 24 hours though. That's good. Glad to hear it. Glad you made it out alive. Okay, so the idea I'm trying to go with today is generating sort of blobby shapes. And I don't know exactly how I want to proceed with that. So, well, let's just kind of build out a weird looking pipeline. Let's go with something like that. So, first of all, let's do that. So this, you know what, let's bring this down to, I don't know, 40. Oops. That's not what I meant to do. We've got curve, width, end segments, and the taper. Yeah, okay, we're good. What did I mess up here? Okay, so I've got one error at the end of this, but I'll sort that out later. So this rendering is a little bit off here on this last point. I'll fix that in a minute. I want to kind of get an idea at least. So my idea is basically before I do a polygon here, I actually want to map cat let's see. Let's map the function. No, sorry. So here's a function I want to map over every point. So it takes a point. And then what does it do? That's the question. So for each point, it does so let's see. Let the circle points be the parametric curve of a circle with a radius of 30 running over. This is confusing, but maybe it'll make sense. Over, yeah, range 0 to 1. Point 1 is fine, I guess. Okay. It's hard to follow right now, but let's just go with it anyway. Okay, so this function takes a single point. Inside the function, it generates a set of circle points. For each of those points, I have to map. Yeah, map. Whoops. Yeah, utils slash v plus. Yeah. So what I'm just doing here is basically doing a translate function. I'm translating each of the circle's points to the point of the generated path. So I'm generating a path of points. I'm putting a circle around each of those, and each of those circles has its own set of points. Then I'm going to do a hull over that, and then it should be this sort of bumpy looking shape. Does any of that make sense? Maybe it makes sense in a minute. Let's see if this actually will work, though. That's the thing, really. So, okay. So now I just have to run this through hull, and then here I actually have to map. So hull returns a sequence of maps, and I just need the point chunk from it. So map point. Okay, Is this... I'm not sure if this will work. Alright, well, let's do this now. Let's break it down one step at a time. Okay, so I broke it here already. So let's map cat this function. Oh, of course. Oh, this is backwards. Wait, is it? Sorry, let me go Clojure as thread. I forget the order of as thread. I also don't know if this is the cleanest way to write it, but I'm just in the REPL, so it's just doesn't have to be super clean necessarily. Right, so you do as P. Alright, so now we've got as thread, so we can kind of clean this up just a smidge. So what am I doing here? So I want to do P like this, then map cat. I can put P at the end of this statement here, like that. Now I can run hull on P, and then map. I can change up like this. Map point over P. This is the one downside of the as thread, is it does often get repetitive, and that's why it's kind of, I think it's usually an unused. It's not used very often, I guess. Just for convention, I guess. Oh, I accidentally committed the result. Yeah, that's not gonna work. Yes, 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 I know. That was a mistake on my part. Oh, that's also not gonna work. Okay, let's try this now. Let's see what happens. Wow. Hardly looks like anything. Let's make this way smaller. I'm not sure that this is actually doing what I think it is. It's certainly making a weird shape. Yes, there's no denying that that's true. That actually is, I can tweak how that looks there. I think this is not doing what I'm hoping it does. And that's okay, I can break it down into a proper function. Let's mix it up with some of this. Oh, missed one thing. This will make weirder shapes. It might not look good. In fact, it's very likely not to. But let's see what it does look like. So the hull is the part that slows this down quite a bit. And also, there happen to be a lot of points that it's trying to calculate with. I don't think it's going to fail, but we'll see. It's taking a lot longer than I thought it would. That's a mistake. I feel like I should cancel it, but I don't want to yet. Hey, it did something. It looks like a Millennium Falcon. Alright, so that's not really behaving the way I really anticipated it. Let me think about this for a second here. Oh, okay, first of all, here, let's bump this way back down to 20. So this is the width of the stroke line. And this is the number of segments that it uses to produce that line, and this is the taper off from each end. Then this function is supposed to just be putting circles everywhere. It might not actually be doing anything, but let's see what this looks like. Hey, C Films. Glad to hear you're doing great. I'm also doing quite well myself. I am feeling good about the work I've set out for myself this week. I'm keeping my streams shorter this week so that I can focus a little bit of dev time off stream. So I can get back into making some YouTube videos again, because I want to do that, build that up to grow this channel and grow the YouTube channel at the same time. Do more generative art, all that kind of stuff. So it got a nice full week ahead of me, but it should be good. Oh, that's an organic looking shape right there. That looks pretty good, I gotta say. Let me take this out of here too, though. See if we get organic shapes. Ooh, null pointer. Don't love that. It's an amoeba. Yeah, so this is actually kind of the shape I was hoping to develop. So let's... Oh man, null pointers all over the gaff. I don't love that. Okay. Why would that... So, okay. Well, let's not keep trying it then. Let me just check this. Okay, so you're working on trying to connect the length of the bars in a graph to a database. Oh, you're making like a bar graph view over some data in your database? That's pretty cool. Okay, so the null pointer exception can crop up here in the tapered stroke. I'm sure that's related to the fact that I'm running random point sets through a Bezier curve and then trying to... Yeah, I might have sort of on the inflection points, you might have, what are they called? Divide by zero type problems. I don't know. I don't like it. I have to figure that out. But like, so these are not organic, right? These are like, they're swoopy and they're cool, but it does kind of work out actually a little bit. Well, first of all, let me try to do the hull calculation on there. Oops. That's the wrong. I need to do this. Is it going to be a null pointer every single time? No, there we go. Okay, so you could check that if it's a problem by just putting in a conditional if the divisor is 0, default to 1, right? Yeah, I could. I'm just trying to think about where the correct, like the most correct place to put that actually is. I don't know for sure where it's cropping up yet. I have a hunch about it being the Bezier curve, but I could just be wrong about that. That's the thing. I've been known to be wrong before. For the sake of getting something, I'm going to... I do have to figure that out. Okay, but before I do, I want to have a bit of a basis for what I'm trying to achieve here. Copy this into a function, and then I'll start tracking down the null pointer issues. One way to do it is try to see if I can... I just need to generate a case and see the input data so that I can purposely set off a null pointer exception and just kind of step through the functions one at a time and figure out what's what. Anyway, blah, blah, blah. Basically, what I've got here is a random Bezier curve with a stroke attached. And what I want to do here is generate circles. Hello? Oh. There we go. It works sometimes. Yeah. Okay, so this is quite good. It's not perfect. I want to tweak a few things yet, but this is approaching the idea that I wanted. Now, actually, now that I think about this for a minute, I want to do one more thing where this is one thing, I love REPL-driven development because you can just like so quickly just make a new thing in the REPL and just kind of explore it from there, you know. It just is enjoyable to me to be able to do that. Let's do P. P is the parametric curves part of my SVG library. I'll show that for a second here. Excuse me. Right, parametric. So it has arc length. Oh, that's a computation function. All right, that's I forgot about that. That's okay. So this parametric, it generates point sets basically. So regular polygon is what it sounds like. You have a radius for the polygon, and n is the number of sides. So you can make a triangle, an equilateral triangle, square, or as a diamond, whatever, and up and up and up. The highest, if you make n really, really high, it looks like a circle. It approximates a circle. Rectangular grid is a grid with number of x, number of y, width and height between each, which should be spacing x and spacing y, but anyway. Hex grid doesn't work yet. Line, these are the ones that get interesting here. So we got line and what? I need to change this. Huh. Anyway, I have to look into that. But point is, stuff like this is what I'm using. So the parametric line returns a function that takes t, a parameter, and then returns a single position. So you can use that to construct all kinds of unique looking things. Do I have the same REPL open in 2 spots? I think I do. That was not what I intended, but anyway. What I was trying to do here is make a circle. Let's do a circle of radius 120. Oh, of course. I didn't, so like I was saying, this is an actual function. I have to run it through something to actually generate. Wait. Oh, of course. Of course. In this case, I made a slight mistake, but that's okay. Right, so what I'll do here, it's a circle, right? So I want to actually run it through range 0 to 1, 0.05, step size of 0.05. What's going on now? What type of shape are you trying to make? So this here was my first sketch. It's like polygons, right? It's very straight geometric shapes, which is cool. But I want to see if I can make sort of blobby shapes. So like an amoeba type shape, something with sort of random squiggles, that kind of thing. That's what I'm trying to do today. A little more organic, random shapes. So I'm just trying to come up with a scheme for that. Of course, here's why. There we go. What? That's so weird. I've not seen that before. Why doesn't that work? Let's rewrite it like this. Sorry, this is this has confused me a bit here. Okay. Okay. Oops. Hello? There we go. All right. I've not seen that before. All right, let's figure this out though. I'm gonna see, is it failing all the way up at the top of this chain? That's working. I also don't need to keep this. Nor should I keep this. Ugh. Okay, that works. I'm gonna guess it starts to fail here, right? Yes. Okay. Okay, so this doesn't seem to do much, to be honest. Now, why might that be? Oh, of course, it's because... Well, okay, so if I... This is gonna look ridiculous, but if I comment out the hull parts... Yeah, okay. Yeah, so the reason it's always going to look like a circle because the hull is just going to draw lines from the tangents of each of those circles. So it's still just going to look like a circle. That's not surprising. That shouldn't be surprising. The reason this looks weird is because I just chained them all together into a single polygon. If I make it a polyline, and then I do fill none, it's just a single line tracing the whole shape out, but that's also not exactly what I was trying to achieve. Spirograph, that's cool. I guess I kind of want so I want a hull, excuse me, I want a hull algorithm, but I also kind of want a, I guess, like a shrink wrap algorithm, which would be a little bit different. It would be... What would it be? I'm just thinking about a strategy that I could come up with. Been half listening while I work, sorry. Oh, no problem. I'm only half explaining what I'm trying to do. So I want to make a sort of organic blobby shape, right? And those they're not purely convex necessarily, right? They have smooth shapes, but they might kind of go in a little bit. So they have some concave elements to it. And I'm trying to think if I can come up with a strategy to create a blob, a convex blob, which I feel pretty close to already. Basically just want to have a few random circles and then do a convex hull of those random circles. And then the strategy is some sort of gravity that'll kind of bulge and shrink elements of it in a sort of smooth fashion. So that's kind of what I'm trying to think through. If that makes any sense. So I'm just trying to think through a strategy like that, basically. But let me first now do... Now I've got a simpler idea here. I'm gonna go here. Let's make this blob gen idea. I see, interesting problem. Yeah, it is kind of a fun challenge. I'm sure I'll come up with something. I already have one idea for the gravity a little bit, where basically for a given random concave shape, calculate its centroid, which I can already do, and generate a ray line from the centroid to whatever point, and they're all going to be points all along the shape. And then so this is the part that I can't visualize perfectly yet, but basically you take that line and you move the point up or down along that line, and you do it in accordance to a sine function or something like that, so that it kind of maps along the edge of the random poly. It kind of maps a sort of sine mutation over it. That's an idea. I don't know if that'll work. Well, I mean, I'm sure I can do that. I just don't know if it'll look the way I'm picturing it looking in my head. Does that make sense? I think so. Anyway, before I get there, let's capture some of this in the actual file here. Okay, so I've come up with a simpler well, let's start with the really basic idea. So let's let C points be random points within a radius, or within a, let's start with 100 by 100 box where they can appear, and I want just 3 of them for now. So for each C point, I want to produce a randomly sized set of what's the word I'm thinking of? What's the word? Circles. Circles? Oh my goodness. I am sorry, I'm getting a little tired today. Okay. That's all right. 3 circles of random radius. That's all I'm trying to do here. So let's just do it in a for loop for point in C points. Let's do let's let the points be created from p/regular polygon points rand int. So the radius is going to be a minimum radius of 50 with a rand int of 50 as well. No, let's make the rand int 100, I guess. So the smallest size is going to be 50. The largest size could be 150. It seems a bit small, but these are just, I pulled these numbers out of nowhere, so it doesn't matter. I can always change them. And ooh, excuse me. And let's make it the segment size 40 every time for now. Map the point to be modified with points like that. I'm not speaking very eloquently today. Apologies for that. But nevertheless, we truck on. Okay, so that, oh, I have to actually bind this to a symbol here. So let's call the actual points the actual base. Yeah, no, that's fine. We'll just call it that. Then the final result of this blob is going to be map the point key over the hull of the points. Okay, that should work. Should be something anyway. So now what I want to do is go over here. Let's go back up to before the as thread stuff here. Probably a ways up now, but there we go. Okay, so let me delete all of this. Just do one call to my new blob function. See. Well, I guess I should run the function first, see if it works, eh? It clearly does not. Also, there we go. Because I did it in a for loop, I didn't map cat it, so that makes a bit of sense. Okay, so let's use that now. Oh, still need to actually call it because it is a function. Oh, that's just a circle. Oh, okay, wait a second. let's make this just 20 every time. What am I missing here? Back in business? Oh, were you you went away from your computer a little bit there? Or are you mentioning that it's not failing anymore? Sorry, I'm spaced out today. I don't know what the deal is. Sorry about that. Oh, that's okay. Past the null pointers. Oh, there's still gonna be there'll be null pointers again, but sometimes when I'm doing this sort of loose sketching and these ideas, I just kind of throw whatever, and it sometimes ends up being an inefficient generation approach. Like I generate 50 random points and the hull ends up returning 10, right? So I can get, without solving the problem, I can come up with more efficient approaches that don't need to use those problems anyway. It's kind of cheating, but oh, you know what? Actually, I'll do this like this. Apply concat to the points. Is that gonna work? There we go. Okay, that's what I'm hoping to see. All right, so here's my idea. This still looks rather geometric, I must say. It's not quite good enough yet. Also, probably, let's make this like 20 points. 20's too many. You know what? Let's make it 7. It's also, just for sake of, no, 200, 150 is probably good. Yeah. All right. So what I was saying, these shapes, they're blob-like, which is good. That's what I'm going for. They've got random radii and sort of random seeming positions, but I'm calling it now. There will be no more null pointer exceptions for today's stream, I believe. Oh my goodness, you are you're calling me out. I love it. That's fantastic. Okay. We'll see how that goes. We'll have to see. Right. So, the next thing to do, now that I've got a thing that kind of generates almost blobs in the way that I want them, I want to add sort of random or like random growth and shrinking to different portions of this. And I'm going to start that with I had it here. This here, excuse me. This deviate function. Oh, I remember. I know what I have to do here. Sorry, I'm temporarily gonna yeah. I'm just remembering how I did this. Okay, so I had this deviate function that this is basic. Okay, here we go. I'm gonna copy that into here and start using that. So deviate works with, you give it a curve, it'll roll to not deviate, or it will deviate. I'm just gonna get rid of that first random roll because I don't really care about that right now. So let ray be a line I mean, let's try that. That seems cool, right? Oops, gotta do it like this. Let's thread last. Points through apply concat. No, let's do it like this. Apply concat to the points. So we have a proper points list. Let's map point over that. And now here, let's map deviate. Oh shoot, this is I forget, C is the wrong, that's a bad parameter for it. It's like C is in, it's in the constant. It's like the it should be factor. It's strength, I guess. Yeah. Well, let's go with it. Anyway, let's do a strength of 1. Oops. Deviate those points. So the strength of 1 from centroid of points. Let's do this. Hard code it for now. Just to, I don't even know if I'm, let's see if this actually has an effect. Oh, gotta define it. Come on. Wait a second, ran T isn't, I don't need that. I can just do this, can't I? Yeah, I'll just do that. I don't need to make a whole new function for that. Let's just do like this. Oh. There we go. Okay, let's try render the blob again. Okay. Okay, let's focus up here. Okay, strength is 1, deviate from the 0, 0 position. And you're mapping that over the points list. Okay, let's try that. Ay, ay, ay. What a day. Well, now what? Well. All right, let's follow this logic through here. So this ray, it's either going to be 1 plus or minus what? Sorry, I think I copied something wrong when I... Oh, yeah. Okay, there we go. Hi. Okay. Okay. It's fine. It's fine. Okay, so this part should work. So it's either... I'm gonna take this out like this. F, the function I use... Seriously? What did I just do? Or get it source abort. Just having a day, everyone. Sorry about that. Hope everyone else is doing all right. Come on. Sorry. Checking messages and stuff. All right. All right. What do we got here? So let's let... There we go. Okay. The function f, you just want to run ray with the result of f is plus or minus. There's going to be 1 plus or minus some random float value times the strength. So in the case of my attempt, the strength was just 1. What changed? What did I do? Sorry everyone, I'm just unfortunately messing things up here. Oh, I did this in the wrong order, right? No. No. Oh, I missed a hull. This is why. Sorry everyone. Okay, so apply concat points, that works. Run a hull. Then you run map point over that. This should give actual point data. There we go. Come on, that took too long. Sorry everyone. Hello? Hello? Please? I'm going crazy here. Alright, there we go. Alright. Now that I think we've got things... I mean, it's working, but it's so not working. Oh, that's hilarious. I mean, it looks pretty cool, but it's definitely not very organic looking. Not organic, not organic. Yeah, Mikey. You have got that right for sure. Okay, but believe it or not, this is actually a step in the right direction. And the reason I say that is just because there's this deviation here is a completely random deviation. I can theoretically map another function over that instead of just randomness, right? So let's, for example, create a constant offset. What would that be? I mean, let's call it constant offset and come up with a better name later. Oh, I'm also going to make this look like that. There we go. All right, we got there though, kinda. Jeez. Okay, so I don't need strength. I need T. Offset from center and make it a point. Okay, so the ray is still a line here. We don't need F to be that. We're gonna actually just make it plus, right? So it's just gonna be ray plus. So it's 1 plus the T strength. So you can pass in, yeah, that makes sense, I think. Okay, so let's now do constant offset from 0, 0 position. The strength T is 1, so that will actually double its distance. So let's make it subtle for now. Let's see if it works. Okay, we're on the right track. So here, this is exactly what it says. This is not a very useful function, actually. It's not really what I want. Right, because it's always gonna it's just gonna be an offset function. That's all it is. And you're still gonna, this is not going to help bring things in and out kind of in a smooth fashion. Like the randomness at least makes concave shapes to it, right? Like it at the very least has that going for it, which it's not right for what I'm trying to achieve, but it is something. So the constant offset is unnecessary, I guess is the right thing to say. The only fun thing I could start to do with it is stuff like this. If I move the position around which it is offset, it might lead to unique shapes. Although I'm not really seeing any of that. The problem, of course, being that I can't compare random from random. That's not helpful. Okay, so let's... I have an idea. Call it organic offset. So there's like a bulge or shrink could work, I guess. The idea is I want to add a little modifier here. Um, angle factor. That is... Yeah, yeah, that's fine, right? Sure. The angle is going to, the angle that I care about is, so there's one line from the center passed into the whole thing and a point. So let's say the center is there, point's there. What I want to do is angle is utils slash angle from points. Center is the center angle, point is the end. Actually, no, let's do, well, it doesn't matter so much. Maybe it does, but here it's going to be utils slash v plus center, and it's going to be along x, so we just do one like that. Okay, so that's the angle. And then the angle factor is just going to be angle divided by 360, because it is in degrees, because degrees are an easy enough way to think about angles. I like radians just fine. What I don't like is having to write math slash pi all the time. It's really a pain in the butt. So I actually prefer to type out degrees like this. Yeah, deal with it. Mathematicians. I'm not some kind of purist here. I don't know what I'm talking about. Just feel free to completely ignore me. I'm just having a day, you know? Alright, let's try that. Oh, it looks weird. I love it, but it's wrong. Oh, let's do a positive offset here. Why don't we? It should also be like mod 90 or something, right? So that it's oops. Right, so you get this, I think you're guaranteed to get a discontinuity like, or a sharp edge like this, because it goes from 360 immediately back to 0, which is not really what I want. I also don't know if this is actually the effect that I'm trying to achieve. Let's see. I'm also, here's how I can temporarily make it unrandom. Excuse me. I guess that's fine for now. Okay, so blob, call it without seed points. What? Oh. That's annoying. I have to, so this function I need to design way better, obviously. I also don't know if it's hard to tell if it's actually working. But the point I was trying to make is I can do def t points, test points as this. And as long as I don't rerun it, then I can do this. And it won't be random. Oh, I lied. Hey, Fairy62, thanks for the follow just now. I really appreciate that. Thanks for tuning in. Thanks for watching. You don't have to answer any questions I have, but tell me if you're interested. How are you doing? I hope you're well. What brings you to the stream? And are you a Clojure dev? Those are kind of the questions I typically ask. I'm always curious, you know, about the different kinds of interests that people have when they come into the stream, you know? But yeah, no need to talk if you don't want, but welcome either way. I hope you're well. Okay. Is there a random element to this that I'm missing? Oh, yeah. Of course. This here. I'm still random. Okay. So the seed isn't doing what I want it to, obviously. Well. All right, let's do it this way then. Let's just get rid of the seed points idea. That's not exactly helping me out. Just get rid of this. Nope. Nope. Hello? There we go. All right, if we do this and we run blob, that should give us a list of points. All right, let's def t points as that. Now we can do, instead of running blob on t points like this, let's run map organic offset 0.200 over t points. Yeah, I keep forgetting to type things. Okay, so now there we go. Now we've got a shape that's not changing, and we can start to tweak these things and see what does change visually. All right, so the organic offset, poorly named, I know. It just kind of scales, so it doesn't change anything. And that's not too surprising, because all we've done is make a relation to the angle that the ray of that particular point has. So if I just do constant offset, it's a very different shape, I'll grant, but wait, why is it so different? It's gonna be so different because, oh, that's right. So the organic offset is a multiple. It's doing 1 plus t and then multiplying it by the angle. So you're almost always going to be quite a small, it's actually going to be quite a small number all of the time. What I should actually do is have it be like this: 1 plus t times AF, like this. Or even just 1 plus t plus 1 times AF. I don't know. I'll have to figure that out. There's ways to do it, but I mean, there's a few ways to change things around. Let me think. If I do math sine of util slash 2 degrees. No, 2 rad, I mean, of let's assume 42 degrees as a test here. Okay, okay, this might be, let's call it I will leave it called organic for now, and that's definitely gonna change, but let's see if this is cool at all. Instead of doing angle factor, let's just take angle directly into our sine function and just use that as the addition here. So it's 1 of the ray plus math sine utils 2 rad of angle. Let's see if that looks cool. I have no idea if it will. No, not really. Not really at all. Right, so that, I need to make a shape that, this offset idea I think could be really cool. I need to have a straight shape to kind of project the function onto it so I get an easier visual of what's happening. So I can make that in just a minute, but I'm going to go to the washroom for a minute. I'll be right back. I won't be long. Feel free to talk amongst yourselves. Heyo, heyo. Oh, hey, Viva raided again. Hey, how's everyone doing? Hope everyone's doing okay. Hey, El Papa Pig. Sorry, I don't really have chatbots set up to do much. If you're curious, blah blah blah. If you are curious what I'm working on today, I can explain it to you briefly. I make this Clojure open source library for SVG elements, SVG CLJ. I use it to make SVG drawings, 2D and 3D stuff. I made this little project, and I've turned it into a little web page. What this page does is generate a random I called it polygen. It's like a generative art sort of idea. inspired by some prints I saw in IKEA the other day. So I coded this up, and the site it runs. You can, so this is the local host, but I actually have it up on my little blog here. Cypress, Polygen. Here you can run it on your own computer if you wanted to. The idea is, and you can save, like you can actually save the generated piece. Anyway, I wanted to challenge myself to make a bunch of generative art sketches. So today I'm working on the next sketch idea I had, which was to make, well, I'm in the process of making a more organic shape generation tool. So let me show you what I mean by that for a moment. If I just do this. So this is, you could call it a blob, but if you look at it, it still kind of looks fairly geometric, right? Like, so all this is, I did a convex hull calculation over 3 randomly positioned circles. So it looks okay, but it's not exactly the blob-like structure that I was envisioning. I wanted more of an amoeba. So one strategy I'm trying to work on right now is to map a sort of organic function. I'm thinking a sine wave over the along the edge of this poly. So that's the next thing I'm trying to work on, and I'm just kind of fumbling my way through it. As you can see, I have a thing that modifies the shape, but it's not modifying it smoothly. So that's what I'm working on. The whole purpose is to make a collection of these sort of art pages. The idea being, by the end of today, if you go to this site, I'll have a little blurb on the bottom saying you can use this for whatever you want, and then a little link to my Patreon and donation and stuff like that. There's kind of twofold ideas. One, three. One, I want to improve my generative art stuff because it's fun and it's exciting. I really like doing it. It's just kind of creative coding, and that's enjoyable for its own purposes. Two, I want to share it out there and have it so that people can use it and take it and either print it out and hang it up, or use it for some other art thing of their own, or just to be out there in the world. The cool thing is they're sites, so I want to kind of add little turn them into interactive blog posts as well, so that I can explain what I was thinking and stuff like that. And then third, I do want to use them to kind of to build up a corpus of my work that I can point to and say, hey, if you like what I'm doing, you can support me through these various tools. So there's that quote unquote hustle element of it too. I hate having to hustle like that, but that is honest. If I'm being totally honest, that's part of it too. See if there's any, interest in the art that people might be interested in supporting that sort of thing in the future. But anyway, that's a whole big tangent. I'm happy with this result, so I'm really excited to see what else I can start to come up with. And that's where I'm at. I hope that makes some sense. If there's anyone else who's just wondering or has questions or anything, go right ahead and ask. I am willing to try and explain myself as much as possible. Also, I'm not sure if Viva's still around, but thanks for the raid. I always appreciate it. I hope your stream went well. And anyone who's from Viva's party, thank you and welcome as well. Feel free to stick around or leave. It's all of that's fine. I just hope everyone's having a good time. That's the truth of it. All right. Okay, let me let me make something of this. Yeah? Why not, right? Let's do, first of all, let me do polyline fill none. Okay. Now, let's def t points as something different. And that something different I want to be, let's see. Let's do map p line. Let's just do negative 100 0 up to positive 100 0. So let's map that function, the line function, over the range 0 to 1.01 with a step size of 0.01. That is a set of points, right? Yep, that's good. It's a lot of points, but let's go with it. And now let's try. Ooh, that's a bad look. Oh, I meant to do this. Okay, there we go. We got how do you increase the frequency of a sine function again? Does that multiply? Ooh, that's a nonlinear. That's cool. Yeah, okay, so 2 pi times... Oh, right, times a function in there. Yeah. Okay, so f is the frequency, I guess? Sine 2 pi f of t. Man, it's been... It's almost embarrassing. Like, engineers, like, we use sine and cosine so, like basically, we live and breathe it. But I just... If I haven't used it directly in a couple days, it just falls right out of my brain. Oh, it's embarrassing. I should be smarter than that. You know what I think it is? I've never, like, really committed to memorizing all of the exact use cases. Like, I just don't have a good mental map of it in my head, and I never have. This is just a weakness. I could fix it. I should fix it. Maybe one day. All right, so I am... So this will fail because... Well, okay, interesting. Is that... This kind of makes sense. Okay, so... Let me think. Here. So let's double this. Right? Let's double that angle so the frequency increases. Cool. Not exactly what I expected, but cool nonetheless. Ooh, it's a little butt crack. Oh, it's like a. Oh, that's cool. That's like a. That's like how you draw seagulls flying in the distance when you're a kid, or when you're an adult with a certain level of artistic skill. Or it looks like a magazine if you're looking at it from the level of the table right down the spine. I'm sorry, I'm distracting myself. Okay, so this is kind of cool. This might actually get me closer to what I want. I should, instead of T, do freak like this. Okay, so now it's a parameter that I can actually use properly. So if I go here, this yeah. Let's make it 1. Okay, let's make it 2. So this is having cool effects, but it is also totally not what I was picturing it to be. Although it kind of does make perfect sense if I really do think about it. I just realized let me def T points as another. Okay. Let's def T points as P regular polygon points. Let's make the radius of it 120. No, we'll just make it 75. No, 100. I don't know why it matters. And the number of points they're going to put on there is just going to be 20. Yeah, 24. All right, so now so this is now a circle. And now it's not a circle. Ooh, that looks cool too. All right, so the center point of this circle is, I know, because I programmed it, is guaranteed to be at 0, 0. It looks like an apple. That's totally not what I want. All right, if I do 0 here, it stays as a circle. Okay, good, cool, love it. Sine wave, frequency, amplitude. Did I put this in the amplitude space by accident? I don't remember. Yeah, amplitude. I'm really sorry that this is so difficult for me. Just struggling today, you know. I don't care about the phase shift, although I kind of technically do, but okay, amplitude is A, so sine there. B, the period is 2 pi over B. So I guess I should do. Is that correct? I don't think this is totally right, but let's see what we get here. I mean, that looks pretty cool. It's not right, but it looks pretty cool. Whoa, I dig it. I love it. Right. So, what am I doing here? What's really going on? Oh, before I answer that, let me see if this has the effects I think it does. Oop. It's so cool. It's so not right, but it's cool. I'm into it. It's a pretty harsh fill. Oop, that's too bright. Just randomly picked that. I don't know that I like that color. Let's just not complicate this. There, that's fine. Okay, so this is not correct. I don't really care about the... So vertical shift actually might be important. Let's see. So I'm realizing, oh, that's cool. That's pretty awesome. This here. Period is 2 pi over b. Yeah. Am I using... Is frequency the wrong word? I can't remember. I forget. Is period and frequent... Like, is frequency just the inverse of period? I don't remember. Maybe? Doesn't matter. I'll figure it out later. I don't really care right now. This is heading in the right direction. It's very cool. In my opinion. So all I've done here, right, is... What was happening before is the ray itself goes from the center point you give it is the 0 position, and then the maximum is the 1 position. So I was doing this math sign, this whole chunk here could be anywhere from -1 to +1. So the total effect can go from literally, it can go to the center point all the way up to double the distance from the original edge. And that's not exactly what I wanted. I kind of want it to be the actual edge with a bit of wave to it, if that makes any sense. So, let's do something different. Also, I do think I've... It looks really cool. This part here is... I don't know how to handle that properly yet, but I'll figure that out. I was saying earlier, I think I didn't finish this thought. It'd be smart to generalize this sort of approach to, say, take a point and a modifying function, or instead of a point, you give a shape and a full modifying function that maps to that shape's edge. So you can always transform it, and then you can just come up with crazier functions. So you could pass in a simple sine wave, you could pass in some kind of nested, not like a nonlinear sine that has a decay to it. So you could actually map things over, like it just generalize it to be way more usable than this. This is not very usable right now. It does produce cool results, though. I won't deny that. I am pretty jazzed about that kind of result right now. Excuse me. Let me. Oop. Let's go back to 0, 0. Let's also bring this number down a little bit. Or up again, because it's fun. Okay, this is too big. It's cool, though. That's pretty neat, actually. I kind of like that. All right, but let me... All right, let's try this again. But let's... frequency from period. I just... Am I using the right terms? I don't think that I am. I will have to instrument this whole thing properly later. Okay, so if I make this 1, it doesn't do much. If I make it 100, it does, okay, it starts to do more. There we go. Okay, let's go with that for now. And let's go here and do 20. And instead of 0, 0, I have to change this up slightly. X points, apply concat points. Oh, no, no, no. Let me do it like this. This whole thing, except for this, is the set of points that I care about right now. Yeah. Now, here, the result, all I want to do is map organic offset over X points, but I want to use util/centroid of points of x points. There we go. That should get us what we want. If I could type properly, there we go. All right, let's try that. Let's go. Blob. That's way more blob-like than things used to be. I'll say that much. Okay, I'm pretty happy with this as a starting point. I don't like these situations here. Things are discontinuous, and that is, I'm sure, or I'm fairly sure, that's related actually to the phase of the wave that I'm trying to map over it. Is that right? Maybe. Let's lower this number. It's definitely heading in the right direction. Pretty happy with that. This is the only, I don't know how I want to proceed with that. What is the correct approach? I ask myself. I'm thinking, I am also checking my messages, but I am thinking about how to handle this. This feels as if I'm on the right track. Kind of, anyway. I gotta go soon, so I can't, I won't be able to finish this up on stream, but I'll finish it up today for sure. All right, let's try. Let's see. Let's see, maybe there's techniques. Blob maker. I've seen this already. This is not, like, those are nice blobs, but it's not quite what I'm going for. It looks good though. See, this is a little more like what I'm trying to go for. That's pretty cool. This is pretty nice. That's sort of the shape I'm trying to envision, honestly. See this? They've got cusps there, but it's all smooth. So what I actually think this is I think these are probably Bezier curves. Let's see. Yeah. So there's a C. C is another curve. Yeah, those are all Bezier curves. Anyway, that's pretty cool. It's a nice interface too. They use the kind of visual concept down there too. All right, enough of that though. That's not, I mean, it's helpful, kinda. Hmm. Oh, that's cool. Okay, so this curvature approach here, if I can generalize that sort of thing. Can I? I don't know what I don't know. Hey, C, how you doing? Squircle, Wolfram Alpha. Let's try that for a second. Well, that's not exactly what. Doing great. Glad to hear it. That's good. That is really good. Okay, so the discontinuity here, it's certainly. I don't know. I don't know what I'm trying to say. I do like it though. Like this is for sure a lot closer than I was before. Maybe I just had this. Maybe if I could make a fillet function. Excuse me, sorry about that. I am a little tired and about to. I'm gonna call it a day soon, but not quite yet. How is the code shape trying going out? It's going well. I'm getting closer to the kind of effect I want. Getting more organic like structures. So this is getting better. There's still these sort of straight pieces that I don't want, but it's an improvement for sure. You're also a little bit tired? Yeah, it happens. It I mean, I don't like it. I don't love being tired, but you know what? That's just the way humans are. I really can't complain too much. I've just got to learn to deal with it, you know? All right, let's see here. Blobs, blobs, blobs. Set this to 0. Yeah. have to head out for the day later. All. Hey, Mike, thanks for tuning in. Thanks for sticking around in the chat a little bit, and have a good one. Hopefully, I'll see you around again, and I hope your night goes well and work continues to treat you nicely and all that good stuff. Have a good one, Mike. Have a good one. What if I do a negative number? I guess it shouldn't really matter. It should it just kind of twists things around on itself, maybe? I'm just wondering now if it's time to shift my thinking from doing things on sets of points to building a parametric polyline and then running a modifier over that. Let's see. Maybe that's the strategy. All right, let's see. Let's try that. Does that make sense to do that? I'm not so sure. I mean, yeah, I guess it kind of does. All right, let me see. I'm going to get going soon, but let me open this up and have a look at... I think I started to come up with something like this. Well, let's literally just, let's copy this and try it as a start. this remap within does not exist here. Is there anything else that's missing? Just that. All right, let's go here. That's gotta be in utils, right? No, it would have to be in brap. Utils. Here we go. Okay, let's try that. Okay, let's see. If I do... ASDF is polyline. P regular polygon points 100, and let's do 6. Okay, so ASDF is a function. So if I do ASDF 0, okay, good. Good. Okay, so now what I want to do actually is still have not got the bar graph links connected to the database. Oh, well, maybe maybe another day you can figure that one out. I'm sure you'll get there. It's just a matter of time, you know? I am certain you can figure it out, though. All right, let's map ASDF over range 0 to 1 as 0.01 like that. Let's try that. Hey, look at that. This, if I increase this, it should still, oh yes, okay. So that actually might be the ticket. That might be the trick to achieving what I want, but meant they are connected, but they're not working correctly. I realized that the music stopped. Why did that happen? Connected but not working correctly. Okay, well, you're one step closer, right? That's exciting. That's a good good progress, right? There we go. Got a bit of chill music going still. I have to go soon, but I'm pretty sure this will be kind of what I want. I see hexagons. Yes. And that's actually, believe it or not, a good thing. Oops. Translate it. There we go. Oh, I goofed. Right, this has to be ASDF. So I like 6-sided objects, is that what you asked me? I mean, sure, I guess. What the heck? I mean, yeah, hexagons are a useful shape, like actually for various reasons, and they're like good in video games and stuff. People use them all the time. All right, here's what I was trying to get at, though. It's not actually just a hexagon. It is a polyline function that will return points anywhere along the hexagon. Although I missed, it's missing one edge here. So I actually have to do, excuse me. I want to make this a, you know what, I'll leave polyline. I'll also make a polygon function here. Why not? And then I should actually copy these into my SVG library because I do believe they could be useful. Right, so the only difference here actually is points. I actually have to do partition 2 by 1 of points, and I want to concat vec. No, sorry, let me do this. Yeah, concat points, first points. And everything else about that should be the same. So let me redef ASDF for a minute here. Instead of running polyline, let's do polygon. And now let's do this again. Ooh. I heard there's a 5-sided shaped building in the world. Have you guys seen a hex-shaped building before? I mean, gazebos. But you mean like a tall skyscraper type thing? No, I don't think so. Maybe? Oh, gazebos are usually 8, I guess, not 6. Or 4. Yeah, anyway. What did I do wrong? That's my question. Do you know what the most famous 5-sided building in the world is? No, I have no idea what you're talking about. Oh, you mean the Pentagon? Like the, maybe, is that what you're getting at? Like the US Pentagon? I feel like that might be what you're actually alluding to. I was totally not paying attention to it at all. And then literally it's called the Pentagon. Okay, you're saying 5-sided to throw me off? Yeah, I was just not picking up on the joke. I've got a bit of tired brain going on right now. That's all right. We got there. We got there in the end. Okay, I need to go very soon. I want to fix this function so that it fills in this corner. And then I'm going to get going after that. what? Let's make it a pentagon there. So I'm still missing that side, obviously. Let's get it back. What did I do wrong? Did I even actually? Yeah, I must have. Yeah, okay. An open 5-sided hexagon. That's not a thing. I mean, technically, because there's no side here, it's arguably an unknown number of sides, right? Like, it's, since it's not closed, it's not a closed shape at all. But if like, you could fill it in with 20 extra sides if you wanted to. 4-sided open pentagon. Yeah, I guess that's... No, that's still... I don't know. It doesn't matter. I just need to fill in that side. That's the goal. That's what I'm trying to get to. Oh, you know what? Probably... No. This won't make the difference, will it? Oh, this is why. Okay, let's change this to be like this. Okay, this should fix my issue. All right, let's try that. There we go. Perfect. All right. Now, since... Okay, so what I've done here is just... I've turned, so I can now pass any point set into this function and get a parametric representation of it. So that just means I can map it's now a continuous function from 0 to 1, and I can get a point along that polygon. Now I should be able to take any other parametric function and add them together to create some new shape. So let's try let A be is going to be polygon, and I'm going to do P regular polygon points. B, I'm just going to make a circle. So that's going to be P circle. That's just going to be a radius of 80. Now this whole thing is going to be a function of T returning let me think about this for a second. T, yeah, it's going to be let is this going to make sense? I don't know, but it might be cool. I'm not adding these up in like the appropriate way, but it is cool. So it might be fun to do. Let's see what happens. Right, so line is a parametric line from A to B at position T. And then the result of this is actually just going to be line T is the result. All right, so let's see what happens. Now, ASDF. Yeah, okay. It's not totally right, but it's a step in the right direction. That is my first attempt at the addition of a circle to a pentagon. It's kind of cool. It's super weird, but it's pretty neat. I kind of dig it. There you go. And so, right, so obviously the issue here is well, it's not an issue. It's just they're not mixed. The result of these isn't mixed. So let me do here. I could actually hard code this value, and then I'll get an even mix of the two. Yeah. Oh yeah, yeah, yeah. This is great. This is very close to what I want now, actually. See that? Oh man, I love that. All right, let's just do half. Yes. Okay. Let's even do negative, and that should pinch it a little bit. Yes. Okay. This is great. These are the things I love to see. Okay. That makes me happy. So let's actually make a function here that blends two functions. So A, B, and then alpha. Yeah. It's a very simple function, actually. Right, so ASDF, now let's go back up to that and just define it like this. Oof, I'll be right back, actually. There we go. Wrong way. All right. What am I doing? Oh yeah. So I'm gonna redefine ASDF in terms of this blend function just to see if it's working the way I expect it to. So if I do a blend with an alpha of 0.2, that'll look like, yeah, it's expanding. If I make it greater, it'll like bubble the shape out, right? I think. Yes. Oh, this is exactly what I need. This is way more powerful now. I can basically generate, like I could just use math functions now to generate combinations of shapes and map them onto any other polygon, basically. That's great. Well, so that's blend. Is that gonna? Yeah. So if I blend 0, oops. Right. That's the first shape. If I blend 1, it should be exactly the second shape. Yes. Okay, that's good. What if I, like, what does it look like if I blend 0.5 blend? Oh, it shrinks the shape as well. Okay. Okay, so this is one way. Okay, so, yeah. So this can be kind of weird, right? Because what if I do an open shape and a closed shape? Why did I do it that way? Let's do P align. Let's try that. What does this look like? It's gonna look weird. Yeah, so also like what if I, okay, last thing and then I have to go. If I do, B is just gonna be math. Let's make it times 10 math sine of yeah. T times 2 times pi, t goes from 0 to 1, so it's a sine function. It's the sine function going just once around. Yeah. All right, let's try that. What is this gonna look like? Nothing. Oh, of course, because the sine function is returning just a value, not a coordinate. that's obviously wrong. Well, let's change it up then, why don't we? Function of t. It's going to return that, and then t, like that. Okay. All right, let's try this. Looks weird. It's not at all sensible, but that's okay. It's a step in the right direction. Well, so that's definitely a sign function, right? It's a cool thing. Right, so this is blend. I need to do some kind of function-based offset. So C has to be the curve, F has to be the modifying function, and that's all that is. So this is different because it's going to return a function of t that works like this. It's going to return, wait, do I want it to, yes, it's going to return a function of t that runs c ft like this. Okay, so now instead of blend, what I want to do is function offset, but B is instead, C, we're going to get rid of that. We don't need it. B is now this function. It's actually just, I don't need this second coordinate weirdness. Okay. This is not right. Okay. That's not correct. I'll have to figure this one out another time. I gotta get going. Thanks everyone for tuning in. I hope everyone has been doing well and continues to do well. If things are not going well for you, hopefully things can shape up soon, and I wish you the best. So I normally take Wednesdays off. I've been taking some Mondays and Fridays off here and there a lot, so depending on how I'm feeling, I might do a stream tomorrow. Not committing to it for sure, I'm not certain. For sure, I'll be back Thursday, and I should be able to make this coming Friday a stream as well. So, guaranteed Thursday, Friday. If you wanna join me then, I'll be streaming around the same time. Probably doing a little bit of 3D work on Thursday and Friday. I feel like that would be closer to the plan I had for the week. So, but anyway, thanks everyone for tuning in. I am gonna get going. I'll be back again either tomorrow or the next day. Have a good one, everyone. Bye-bye.